Earth's magnetic field acts like a giant, invisible shield protecting us from harmful solar radiation. Without it, the solar wind, a constant stream of charged particles from the sun, would strip away our atmosphere and expose us to dangerous levels of radiation. This video explains how this crucial defense system works. The solar wind consists of charged particles streaming from the sun at high speeds. With Earth's magnetic field, these particles are deflected around our planet, protecting the atmosphere and life on the surface. It all begins deep within our planet's core. Earth's magnetic field is generated deep within the planet by a process called the geodynamo. This powerful mechanism occurs in the Earth's outer core, where molten iron creates the invisible force that protects our planet. The outer core consists of molten iron and nickel that flows like a liquid metal. This movement is driven by intense heat from the solidification of the inner core below. As the inner core solidifies, it releases heat that rises through the outer core, creating convection currents. These currents carry the molten iron in large-scale flows throughout the outer core. Earth's rotation adds another crucial element, the Coriolis effect. This force causes the convection currents to roll and twist, organizing the molten iron into large, spiraling flows. As the molten iron moves through Earth's magnetic field, it generates electrical currents. These currents, in turn, create and maintain the planet's magnetic field through electromagnetic induction. The resulting magnetic field is a dipole field that extends approximately 65,000 kilometers into space, forming what we call the magnetosphere. This invisible shield protects Earth from harmful solar radiation. The geodynamo is dynamic and ever-changing. The magnetic field's strength fluctuates, and its poles can even reverse over thousands of years as the molten iron continues its complex dance in Earth's core. Earth's magnetic field extends into space, creating the magnetosphere, a protective bubble that surrounds our planet. The sun constantly emits a stream of charged particles called the solar wind. These high-energy particles travel toward Earth at speeds up to 1,500 kilometers per second. The magnetosphere deflects this solar wind. On the side facing the sun, called the sunward side, the magnetosphere compresses against the incoming particles. On the opposite side, away from the sun, the magnetosphere stretches out into a long tail called the magnetotail. Charged particles from the solar wind are deflected around the magnetosphere, preventing most of them from reaching Earth's surface and atmosphere. This protective shield maintains Earth's habitable environment by blocking harmful radiation and preserving our atmosphere. The magnetosphere deflects the solar wind in a specific way. Charged particles from the sun approach Earth, but the magnetic field creates a protective bubble around our planet. The boundary where Earth's magnetic field meets the solar wind is called the magnetopause. This invisible wall compresses the field on the sunward side and creates a shield against harmful radiation. Most solar particles are diverted around Earth, flowing around the magnetopause and continuing into space. This deflection prevents them from reaching the surface and stripping away our atmosphere. Some particles become trapped in the Van Allen radiation belts, donut-shaped zones of high-energy particles orbiting Earth. These belts act as natural particle accelerators, containing dangerous radiation. The magnetic field also bends away high-energy cosmic rays from beyond our solar system. These particles are deflected around Earth, preventing them from reaching the surface where they could harm life. In summary, the magnetosphere works by creating boundaries and trapping zones that protect Earth from solar and cosmic radiation, ensuring our planet remains habitable. A beautiful demonstration of the magnetic field's protective function is the aurora borealis, or northern lights, and the aurora australis, or southern lights. These stunning light displays in the sky occur when solar particles are funneled toward Earth's poles by the magnetic field. Charged particles from the solar wind stream toward Earth. The magnetic field guides these particles along field lines toward the polar regions, where the field is strongest. At the poles, the particles collide with atmospheric gases like oxygen and nitrogen. These collisions excite the gas molecules, causing them to emit light as they return to their normal state. Green lights come from oxygen atoms, while red and purple hues come from nitrogen molecules. These auroras are not just beautiful spectacles. They are visible proof that Earth's magnetic field is protecting us by safely channeling harmful solar radiation away from the planet's surface and inhabited regions. While effective, Earth's magnetic field is weakening. Satellite data shows a strength decline of about 5% over the last century, with faster weakening in some regions. The South Atlantic anomaly is an area over South America and the Atlantic where the field is particularly weak, allowing more radiation to penetrate. This poses risks to satellites and astronauts. As Earth's magnetic field weakens, our planet becomes more vulnerable to space weather events like solar flares and coronal mass ejections. Solar flares and coronal mass ejections, or CMEs, are massive bursts of energy and charged particles from the sun that can trigger geomagnetic storms. These storms can disrupt power grids by inducing currents that overload electrical systems, interfere with GPS navigation, and damage satellite electronics. Additionally, increased radiation penetration through weak points in the magnetic field can elevate cancer risks, particularly for frequent air travelers and astronauts exposed to higher doses. To address these threats, we must monitor space weather through satellites and observatories and prepare infrastructure with better shielding and backup systems. Mars serves as a powerful example of what happens without a magnetic field. Unlike Earth, Mars lacks this protective shield, allowing solar wind to erode its atmosphere over billions of years. This relentless bombardment stripped away most of Mars's air and water, transforming a potentially habitable world into the cold, barren planet we see today. In contrast, Earth's magnetic field acts as an invisible armor, deflecting harmful solar radiation and trapping charged particles in the Van Allen belts. This protection has preserved our atmosphere, oceans, and the conditions necessary for life to thrive on our planet. The stark difference between Mars and Earth underscores the critical importance of our magnetic field. Without it, solar wind could erode our atmosphere just as it did on Mars, making Earth uninhabitable and highlighting why this natural shield is essential for sustaining life.